So to start this video, we're going to look at graphs of b to the x, and I should say properties of those graphs. So I'm going to have a list of things here. First, I want you to pause the video and look at what we did in the previous section lecture, and look at A and B. Look at their graphs, and I want you to write what you see that they have in common, some characteristics of them. So go ahead and pause the video and do that, and then I'll get into what I want to show you. All right, so let's look. We're going to say this is number 1. So if here, notice in part A, our B is it's greater than 1, and over here it's between 0 and 1. And so those are significant because you need to remember that B has to be greater than 0, and B cannot equal 1. So these are our only two options. Either B is going to be greater than 1, or it's going to be between 0 and 1. So these are our two options here. And notice, if B is greater than 1, we have an increasing function. Remember, read from left to right. Going from left to right, we're increasing. So if our B is greater than 1, it's an increasing function. If our B is between 0 and 1, then it's a decreasing function. So that's going to be part 1. If B is greater than 0, we have an increasing exponential function. And I'm just going to say expo func to shorten my writing here. Sometimes you'll hear this called an exponential growth function. Exponential growth. Part 2, and really this is part of number 1 still, but we'll call it number 2. If B, now watch what I'm doing here. I'm saying if B is between 0 and 1. So if you actually read it left to right, it's saying 0 is less than B and B is less than 1. But you can view it as B is between these two numbers. So B is between 0 and 1. So such as 1/2, 1/3, any type of fraction like that. Then it's a decreasing function, decreasing expo function. And you'll hear this referred to as a decay function, an exponential decay function. And I'm just not going to write function, but exponential decay. So those are our two options for B. Sorry, these can't. All right, let's go to number 3. What about the domain of an exponential function? Pause the video and you try. This is good practice. So remember what the definition of domain is. It's x values. So you notice no matter which way you go, these graphs are going to use up all the x values. So this is all real numbers, negative infinity to infinity. Number 4 is the range. Go ahead and pause and try to do that yourself. Remember that the range is a set of y values, so you need to come up here on the y-axis and see what values we use. Notice this graph is going forever in this direction, and it's never coming down here to the negative side. So this is what's going to be what's called an asymptote, the horizontal asymptote. So it's never going to touch this line, which is 0. So your range is 0 up to infinity, and we're not including 0 because that is an asymptote, which we'll write here in a second. And notice it's the same for up here too. So I spoiled this one, but we have a horizontal asymptote of y equals 0 on both graphs. And of course that will change depending if you had a +3 or a -3 out here, because remember, if you have something on the outside of your function, it moves your function up and down. So your horizontal asymptote will change depending if you have anything written out here. All right, and then last, what else do these have in common? They share this point, 0, 1. So the function passes through 0, 1. So no matter which one of these, it passes through 0, 1. And of course, that's going to change again depending if you have a plus or a minus out here when you're transforming these graphs. So when you move up and down, that point changes also. But in general, these are always going to pass through the same point. All right. Now, what I want to look at is a special function here. It's called an exponential function of base e. And e was discovered long ago, and e is used in the real world all over the place. And I'm going to show you what e is. E is actually a number, and it was discovered, we think, by a finance person back in the day. But I'm just going to show you the function and how it was discovered and how it was explained. So let's just call this example 1. And let's say use a T-chart to express the value of, and let's say f of x equals 1 plus 1 over x raised to the x power. And so I'm going to show you as we increase the value of x, as x gets larger and larger, so notice we have an x here on this small little fraction, and then we have this x up here. So as x gets bigger and bigger, this little fraction gets smaller and smaller. So if x is 2, this is 1/2, and then add this together is 1.5, 1.5. But let's say x was 100, now this little fraction here is 0.1. Then 1 plus 0.1 is 1.1, which is even smaller. So as x gets bigger and bigger, the inside here gets smaller and smaller. But you're multiplying by an increasing bigger number. So what we find is that this will actually equal e. And we named it e based on the person that discovered it. So let's just do a quick T-chart here, and I want to show you that number, just so you can see how the number came about. And so let's plug in 100 in here. If you plug 100 in here, which means you get 1 plus 1 over 100, which is 1.1, then 1.1 raised to 100 power, you get 2.70481 and it just keeps going. I'm not going to write too many of these out. Let's say I choose 10,000 for x. Then this is 2.7181459, and it just keeps going. All right, let's skip up to 1,000,000. If you go to 1,000,000, you get 2.71828, and it just keeps going. Now let's jump up to 1 billion. And I'm going to stop with 1 billion because I think I've made my point. 2.718281827, and it keeps going. So this brings rise to the value of e. So what we say here is that e, as x gets larger and larger, then this value becomes what we call e, which is equal to roughly 2.72, just rounding this up. And if you want to use 3 decimal places, that's okay. 3 would be 2.718. And so the way you plug this in the calculator is there's an E button on there, and if you have a TI-84 or 83, you have to click the second button in the top left and then come down on the left side and click the LN button, and that will populate an E for you. All right, just to show you what the graph of E looks like, e to the x power, excuse me, that's what I want to show you. So example 2, and you're going to see E for the rest of chapter 4. It's very important, and I encourage you to look up real world examples of this. Graph, let's call it g of x equals e to the x power. Now, is this an exponential function? Yes, because e is greater than 0 and it's not 1. Remember, we said e was 2.718 and it kept going. So it is a number and it is greater than 0 and not equal to 1, and then our variables in that exponent. So just to graph it real quick, and it looks very similar to the examples we've done already. And so I'm not going to, you can plug all the x's into your calculator. So if I were to plug 0 into this function, what do I get? And I didn't mean to draw that dot there, my bad. X equals 0, I get 1. Any of these functions, that's always the case. All right, if I plug in 1, so try this and find it in your calculator. Once you find the E button, it's second LN, and then you'll get something that looks like this, E with a caret, or it may look a little different, but you'll get something along this lines. And then it will ask you to plug in something, plug in 1, and out will pop 271828, and it keeps going. So we get roughly, let's say, a point there. And then try again, e raised to the second power, and you get 7.389, and it keeps going. So at 2, I get something way up here already. So this is what exponential is doing. As you start building upon something such as the stock market or AI's intelligence, as you learn more, as you start learning, the more you learn, and the more you learn, even more you start learning. So, and then you can try e to the negative 1 power. Remember, I'm just plugging in x's. And so that will get you 0.368, which is right here. And it looks very similar to our other graphs. All right, so that's E. I encourage you to look up real world examples of E. It will probably be helpful to you.